Hello, welcome to a day on arcsine and arctangent. Uh, we've already learned about arc cosine, and now we're going to see how arcsine and arctangent operate. So first, let's draw and label two triangles of each of these three functions. So cosine of theta is 3 over 5. That means the adjacent over hypotenuse is 3 out of 5. Now there's something I want to tell you about. Since this is positive, there's a short little method that people use to see where cosine, sine, and tangent are positive and negative. And you write C, A, S, T. What this means is in quadrant 1, all three of these are positive. In quadrant 2, only sine is positive and tangent and cosine are negative. In quadrant 3, tangent is positive, cosine and sine negative. And quadrant 4, cosine is the one that's positive and the other two are negative. So since cosine is positive, it's going to be in the all and in quadrant 4. And that would be 3 out of 5. And it should make sense. Adjacent is positive 3 over positive 5. Sine is going to be in 1 and 2. So we can draw these two out. 3 over 5. There's one more thing I want to say about these four letters. Some people remember it by saying all scholars take calculus, and then they go around the circle like this. I've had other students that say that it just spells cast if they start at C-A-S-T and go around. Whichever method you want to use, go right ahead and use. All right, now let's look at tangent. Tangent of theta is 3 over 5. Tangent is positive in quadrant 1 and quadrant 4. So it'll be 3 over 5 and 3 over 5. So these are where these are all positive. Now if I flip this to negative, it's just the opposite. So cosine was positive on the right-hand side. So if I did C-A-S-T, so then it's going to be negative in quadrants 3 and 4. So that would be negative 2 over 7. Sine is negative in the two bottom quadrants, 3 and 4. Because the opposite side is negative 2, the hypotenuse is 7. Tangent is opposite in these two quadrants. This would be 2 over negative 7, and this would be negative 2 over 7. So these are the different triangles that we can generate. These are the triangles when our ratio is positive. These are the triangles that are generated when it's negative. So as we learned yesterday, cosine is in these two quadrants. And if it's negative, it's in the other two quadrants. So if we want to look for a general rule for this, we call that arc cosine. And this would be theta. This would be negative theta. Just as over here, this would be theta, and this would be negative theta. So to get all the solutions, what we'd want to do is take the inverse or the positive and negative of the inverse cosine. So let's say if we use this value being a and b, so my adjacent is a, and my hypotenuse is b. So the inverse cosine of a over b. And then we're going to keep going around the circle for the infinite amount of solutions. So we're going to add 360n to that. And this is going to work whether it's positive or negative, because theta is always going to be either the positive and negative of the inverse cosine, and then adding 360n to that. So we wrote this out formally like this, where our cosine is positive and negative, inverse cosine plus 360n. And if it's radians, we said 2 pi n. So that's what we do when we're dealing with cosine. Now when we have sine, sine is going to be positive, if I fill out my letters, in the top two quadrants. So sine is going to be positive in the top two quadrants. Now when I take inverse sine of theta, I'm going to get this value. So that's going to be my inverse sine. To get this value over here, I'm going to have to take 180 minus that inverse sine. So if we called this, say, a over b, so it'd be the inverse sine of a over b. And this one is just the inverse sine of a over b. So that's how I get my two solutions. Inverse sine of a over b and 180 minus the inverse sine of a over b. But remember, this will have an infinite amount of solutions, so I'll have to add 360n to both of these equations. So theta is inverse sine of a over b plus 360n. So at this point, and then every 360 degree, or every angle that would be coterminal, we could say. And then 180 minus the inverse sine of a over b plus 360n. And that would be the point over here plus all of those values. Now that's also going to work if sine is negative, because sine being negative is going to be down here. So this would now be our theta, which would be a negative value. And 180 minus a negative value would be like adding theta to this. So that would be how we would get the value over there. So this works if sine of theta is positive or if it's negative. Now that is our arcsine. So if we have sine of theta is equal to a, we'll use these top two. And for sine, we have two equations. Inverse sine plus 360n and 180 minus the inverse sine of 360 plus 280 plus 360n. For arcsine, we instead of 360, we use 2 pi. And instead of 180 degrees, we just use pi. So it's just like converting all of these degree values to radians. So it might look like a lot of an equation, but really it's just half of it. Now, this has two equations. Arc cosine actually has two equations for each, but it works out well to just say plus or minus. But keep in mind that this does represent two equations. However, we can't write sine as nicely as we do cosine. All right, now we're on to tangent. Tangent is positive in these two quadrants. Tangent is negative in these two quadrants. So to find our first value, I can just take the inverse tangent. We can say a over b again. If I take the inverse tangent of a over b, I will get the value here. Forget my little -1 on my inverse tangent. Now remember, inverse tangent just gives us one value. Now if I want to find all the values for tan of theta at a particular point, what we have to do is find the values here, and then 360 plus each of these. Now tangent is really nice, because what I want to do to inverse tangent is add 180 to that, because these two are the same angles. So if I add 180, I would get here, which tells us that this is 180 degrees apart. And these are also 180 degrees apart. So if I just take my inverse tangent, I don't need two equations if I add 180 degrees each time we go around. So the first one will give us this point, add 180 to get to this point. If we add 180, we'll get back to our original location. And we can keep adding or subtracting 180 degrees and find all of those values. So this is our equation for arctangent. So our arctangent of A is inverse tangent plus 180n, but if we do that in radians, it's just going to be plus pi n. All right, let's do a couple of these. First off, arcsine of 4/7. What's tough about arcsine is when you see this, just know you'll have to write two equations. So our first equation is going to be the inverse sine of 4/7 plus 360n. Our other equation is going to be 180 minus the inverse sine of 4/7 plus 360n. So now we just take out a calculator. This is in degree mode, so make sure your calculator's in degree mode. And if I type in inverse sine of 4/7, I get 34.8 plus 360n. If I take 180 minus that value, I get 145.15, which I guess would roll up to 2, plus 360n. So these are my general equations, or general solution. Write that in the middle. General solution. However, it also tells us to find the specific solutions for this interval between 0 and 720. So our specific values between 0 and 720, and it's including both 0 and 720, which actually doesn't make a difference in this problem. But for these, we know 34.8 is in that interval. We know 145.2 is in that interval. If I add 360 to 142, that just goes up to 505.2. If I add 360 to 34.8, that's going to be 394.8. If I add 360 to either of these numbers, I go over. If I subtract 360 from either of these numbers, I go under. So these are all the values between 0 and 720 degrees. Now we can look at the arctangent of 9/4. So arctangent, like I said earlier, is nice and easy because this converts to the inverse tangent if we just add 180n to it. That's a pretty easy conversion, just one equation. So now you take out your trusty calculator and type in 9 divided by 4, and that becomes 66.03. I'm fine with just 66. So this right here is our general solution. This will give us all values for theta which are true. So now if I want to find my specific solution between negative 360 and 360, we know 66 is an answer. If I add 180 to 66, I get 246. If I add 180 to that, I'll be over 360. So now I just take 180 from 66, and I get negative 114, and subtract out another 180, and I get negative 294. So those are my specific answers in the given interval, negative 360 to 360. All right, now we have arcsine, and we have an x out front. The x should be a key that we are now in radian mode. So make sure you switch your calculator to radian mode. All right, but most of it we do the same exact way. Arcsine should tell you that we're going to use two equations. So we're going to divide this into inverse sine of negative 2/3 plus 2 pi n. And now we're going to take pi minus my inverse sine of negative 2/3 plus 2 pi n. So I just used my inverse sine or arcsine equation to make these two equations. Now with my calculator in radian mode, I just take the inverse sine of negative 2/3 and I get something that says negative 0.7297. And now if I take pi minus that value, I get x is equal to 3.8713 plus 2 pi n. All right, so now these are our general solutions, both of these equations. Now to find our specific solutions between negative 2 pi and 2 pi, now remember 2 pi is about 6.28. So we're going from negative 6.28 to 6.28. So this is one solution, negative 0.7297. That fits in the interval. 3.8713 also fits in that interval. If I add 2 pi to my first one, or subtract 2 pi from my last one, I'll get my two other values. So this one would be 5.5535, going out to 4 decimals here. 3 would have been sufficient also. And the other one would be negative 2.4119. So those are our specific solutions in that interval. Now we do arctan. Arctan's nice and easy, which is just we take the inverse tan of 4.3 and we add a pi n to it. So take the inverse tangent of 4 over 3. I got 0.927. Add pi to that. So we're going from 0 to 4 pi. So 4 pi is 12.566. So this is the interval we need to stick between. So our first value is 0.927. If I subtract pi from that, of course is going to be too low. So 0.927 plus pi will give us 4.069. And if I add pi to that, I get 7.210. And I add pi to that, I get 10.352. Add pi to that, and I'm over. So these are our specific solutions for x. All right, we made it through the video. Hopefully that helps you understand arctangent and arcsine.